I'm Olivier Casse from Verifysoft. So this is a German company, but probably, as you will hear to my accent, I'm not English or German or Swedish. I'm French, actually. Today we'll talk about code coverage for embedded targets and tool qualification, which is related for safety critical projects. Just talking about the agenda of today, we'll have a look to safety standard conformance to various industries requesting to use code coverage in order to be compliant with safety critical rules. Then we talk more about the coverage levels, which are mandatory for most of these standards. The recommendations they do to these users of coverage levels. Then, in order to certify the software generated with this safety critical project, you have to go through a tool qualification in order to prove that the tool is safe compared to the results you can expect by using this tool for your project. We'll talk about the techniques and state of the art, and we'll focus more precisely on our tool set, which is Testwell CTC++. Then we'll talk about the challenge for small targets. You will see a number of tools available on the market able to provide coverage levels, including free tools, but not all are able to do the same on all targets. And we are experts in providing solutions for very small targets, very tiny. We see that small targets we mean with a lot of a lack of memory resources such as RAM and ROM, for instance, or very tiny microcontrollers which are running a few kilobytes of memory. Then we'll talk for this, in order to achieve this, how we optimize the code instrumentation in order to use minimum resources on the target. And then at the conclusion we'll take some examples. So just to introduce safety standard and a bit of vocabulary, we talk about this picture, which is more or less a V-cycle, a flat V-cycle. Just from the left part, you can achieve some testing at the function level, then at the class or chain test level, then on module level or unit testing level, then go through integration system. And on the left part, we talk about the system requirement level. And then on the right part, but this is another story, we talk about validation and to, at the user level, requirement coverage with some other tools. So again, this picture is more or less a flat V-model that I guess you all know. So test coverage is about checking that you test correctly your software at the various levels, as you can see here. So, as an introduction, I'll talk more about all coverage levels needed across the industry, but I will focus here more on the aerospace industry, where we are classifying the critical aspect of the software from no effect, if this is for, in a plane, for instance, the entertainment. So when you are watching a film, a video in the plane, there is no critical issue if there is a frozen picture or if it doesn't work. Okay, it's a pain. You will spend your whole flight without any video, but this is not critical for life. But more and more, we can have some other aspects and where people life could be engaged, and then we need to have very safe system. So I mean very safe system and software, and we need to prove that the behavior is safe and there is no possible problems due to the software. So this is called DAL, which stands for Development Assurance Level, and this is used in the DO178 standard. I will just talk a little bit later. So coverage level, some basics. So we took a very simple example. So this is a C program, but it could be Java, C++, C#. This is not really important. So just to focus on the terms we will use later on, we talk about functions. So we'll see that this is the easiest, the simplest level that safety standard requests is to prove that you run the functions that it wants. So it's quite easy. Then you can do the same at the line or statements or nodes level in order to prove that you go through all lines. So again, this is quite a simple level. You can check branches. This is more difficult to prove because you need to check for that what we call conditions, which are Boolean expressions. What is needed in order to check if then else or case go to conditions in the software in order to evaluate all possible branches in your software. So we are going more and more in the complexity of covering the levels. So this is another picture where again we are going from the easiest level, the function level, to more complex levels. For instance, here we are talking about a line coverage. So line and statement, this is the same, just different terms. And this is called the C0 level. Then the branch level, when it's called C1, and some other levels for the pass, checking pass execution of the software with very complex situation. And on the right part, this is what we call the condition level category, where you will evaluate Boolean expressions from very simple to complex with multiple conditions, and they are quite difficult to check. So this is what you can read in books and papers about coverage levels in various industries, not only for safety critical, but for all people making software. And this is here where we focus for safety critical projects, because this is the levels that are requested by safety standards. And I have a couple of slides explaining this very soon. So we need to focus on function, statement, branch levels for, let's say, the simplest levels. And then for condition level, you will see that MCDC, or Modified Condition Decision Coverage, it's quite famous because it's requested for the highest level of safety critical projects. And the multi-condition coverage, which is, let's say, the best possible level you could have, but quite complex to achieve in writing the test vectors. So, this is a very simple example. So it's just, again, in C, where you have a function called goo, with 3 integers, which are used as parameters, and where you check that the 3 integers A, B, C, so if A greater than 0 or B greater than 0 and C greater than 0, then you return X with the value 1, and in all the cases you return 0 for X. Quite a simple example. And on the right part, we just translate this C language expressions, so what have been designed by the developer, and the possible paths, so the control flow diagram, which will be needed. And for the colors, so you have for S in yellow the starting point, for E the exit point, and in green you have all possible passes, so P for passes, and B for branches in red. So we just translate, and the goal, the role of the test engineer is to write test vectors in order to check all these paths in order to prove that the software behaves correctly. So this is well-known techniques in the embedded world. So we go through all various function level, condition level, etc. So the first level, very simple. We are using a unit test tool, and we can use any unit test tool available on the market. This one is very simple. It's only either file you need to use in your application. And you write in red, you can see that for view, the three parameters values will be 1, 0, 1, and then the result, expected result, should be 1. So in blue, purple, you can see that this is what we call a test bench. And this test bench is run against your software on the test here in the gray box. And this is the result. So we have one test, one session, and 0 failures. That means that the test run okay. So this is the results. So we can export in HTML format, for instance, the coverage report with very important information, which is the TER, standing for Test Effectiveness Ratio. And of course, the goal is to be as close as possible as 100%. So at the function level, it's quite easy to achieve this. We have only one function here, so it's very easy, so no surprise, 100%. Then we do the same for statement coverage. We remember this is line coverage, and we use the same test vector. And of course, I'm sure here I won't achieve a 100% coverage because I need to have more test vector to cover all the statements. And also, no surprise here, I'm only getting those results. So one statement is missing actually for covering the whole software. Okay, we go through other coverage levels. So branches. Branches means that for conditions, you not only need to check if the result is true, but also the false condition. So that means we need to write at least 2 vectors in order to check if the result is true or if the result is false, in order to prove that the branch coverage levels has been achieved correctly. So let's see if we succeeded. Yes, no problem. By using the 2 vectors, we are able at the branch coverage level to cover 100% coverage. And here we'll talk about the MCDC condition level. And this is more complex vectors to write. Actually, it works as pairwise of test vectors. That means that each time for each condition level you want to check, you need to check for the true and the false condition. So this is why we're using pairs for this checking. So the goal is to find any combination of test vectors to achieve the best coverage levels. And the rule is very simple. You need to have the number of values plus 1 in order to have normally to achieve 100%. So here we have 3 atomic conditions, which are our integers, A, B, C. If I had 1, I need to have 4 vectors to achieve MCDC coverage, at least. So with the other conditions, I won't go into too much details. But here, this is my guess. I say, okay, I will try first with 3 vectors, and let's see if the tools can help me to go further and to achieve 100% coverage. So I run the check, and of course, as expected, I'm not getting 100%, but 86. You can see in red on top of this report, and I can zoom it. Here, by just having the mouse over the vector, you can see the pair which is related to this, and if this condition has been executed or not. Here it has been executed, not here. So in order to improve my test vectors, my work is to write a vector with A equals to true, B we don't care, and C to false, and I will normally go up to 100%. So this is what we'll do here, and hopefully we'll go to 100% coverage. Okay, so now we'll see how industries are requesting the levels in order to achieve safety critical projects. So let's start with the, let's say, the mother safety standard, which is this 61408, and this is reused in other industries with, let's say, some very tiny changes depending on the industry specificities. And you can see with the plus or the plus plus which level is needed for the seal, which is a safety integrity level, so seal 1 to seal 4 for the less critical to the most critical one, okay? And you will see that for seal 4 you need to run function, statement, branch, and MCDC. For seal 1 it will be good to do function, but if you don't do any statement or branch or MCDC, it's not that crucial. So now, let's focus on the railway industry, so known also as Senelec. And this is more or less the same principle, except that we go from seal 0 to seal 4 here, and not seal 1 to seal 4. But this is quite similar. And here we don't have plus or plus plus, but recommended or highly recommended. But this is very similar, no big changes. Automotive, again, this is based on the same mother safety standard, except that here we're not talking about seal but AZ, A standing for automotive, but it's from A to D, like seal 1 to seal 4. It's the same situation, and you can see that we have to cover statement, branch, MCDC, or function and call for the software architecture level, which is higher than the software unit level. So again, we see that all coverage we described are needed in this situation. For medical, it's more vague. It just you can read. It's just not really mandatory, but let's say recommendation to use this kind of coverage. But I think things are moving, it will change in the future. What we just see at the beginning, it's about aircraft. So the DO 178, B or C, and this is coming from level E to A. And you can see that for A, so the most critical one, where people's lives could be taken by crashing the plane, you need to run both MCDC, C1 and C0, so which are the statement and the condition coverage. Okay. Let's talk now about tool qualification, and again we focus on the DO 178 and the DO 330, which is a chapter describing relating to tools actually, and how the tool should be qualified in order to have the software certified. There is two parts. First one, which is related to the tool developer. He has to prove and provide numbers of things. And the other one, which is related to the user, because each project has specific setup, specific usage of the tool, and you need to describe precisely how you use the tool to prove that you use it correctly, and the tool provides no defect. So various credit can be get by using confidence in the tool and precising what you're using for inputs, etc. I won't go too further in those details. I hope you can read this picture. Actually, it's just a matter of how the tool is used. Is it used correctly? We mean by using the right requirements, so the tool operational requirements that the tool vendor provides. So does the user follow exactly this recommendation? Is the tool installed properly? Of course, if the installation is not done as it should be, it could run into problems. So the same if the tool has bugs, so it could happen, of course. Or if the tool is not used in the right context or the environment, the version, etc. So it's a lot of values, variables which are describing the project context for the user to run through the qualification. So the goal of tool qualification is to help the user to write the documentation that will be part of the certification folder. And here he needs to choose which level or two qualification he has to achieve to prove that it's working correctly. At Verifysoft we provide a tool qualification kit which is available for most safety standards, as you can see, so you need to select which one you want to use, but it's available for all those standards. And the goal, for instance, for you, for avionics, is to help you to choose which method will be used, which kind of analysis, which level tool qualification you need, etc. So we provide a complete tool kit that will help to produce documentation, reports, and check how the tool is running in the context with some unit testing of the tools. So the techniques we use for coverage is called instrumentation, and the principle is quite simple. You need to have a tool which shows which part of the code has been executed or not. So here we have in blue the part which has been executed, and in red the part which is not. And you will get what we call the test effectiveness ratio, which is percentage of the test covering those possibilities. So those results are stored in counters with some variables, and each time you go through a path branches or you meet this condition, this Boolean result, when we put just a variable with some values, and then later on we're able to generate the coverage report. So this is just the classical process to get a binary, an executable on a target, or from C and EDOS files, compiler, linker. I think there is no surprise, and you need to have some amount of ROM or RAM used. Here we introduce the instrumentation phase, where we just get at the first result a symbolic file, mandansim, which is the all possible path conditions values for the software. And then we compile and link these instrumented source files. We get an executable, so instrumented executable. And then by providing the unit testing, we get as a result a data file, which is called mandandat, with all just values information in it. So now in order to generate the report, we just need to compare the two and we produce a report. That is. But the problem is that by using instrumentation, you need more resources in ROM or in RAM in order to run the instrumentation part and to store the variables of the counters. So how do you manage this? So in our practical experience, the reason to not have enough memory is for RAM, and in some situation, ROM. So we have to focus more on RAM in order to be able to run the coverage on the target. Again, we are talking about running on a target, and it could be a very compact, a very tiny target. Most embedded targets doesn't have any file systems. That means you can't run printf or scanf command on this target. We just not have it running on a target, with GTAG or whatever, and we can save the counters back to the host, to the PC, in order to run our information. So I'm running. But I won't focus on talking too much on this. So this feature is just for most coverage tools, which the technique is to split the coverage in several parts in order to be able to run on the target, because we are not able to optimize the amount of memory which is needed. With our solutions, as we explained soon, we're able to optimize using various techniques with, let's say, a size of the counter which is different depending on your software and its complexity. and also using the bit coverage technique, where we don't store any time we go through a branch or condition, but only we have a flag which says that, okay, at least once we run through this condition, and that's enough for covering this level. Also, we are able to provide very specific hardware support optimization at the instruction set level in order to minimize the memory which is used at the ROM level, for instance, here. So some numbers, because very often people are asking, okay, but which kind of memory do you need to run instrumentation? So here are some numbers for this function. You will have here for ROM, we're needing a few bytes or hundreds of bytes, and for RAM this is very low. You can see even for condition level, it's not a byte, it's 7 bit. For this example. Okay, I think I am almost done with my presentation. So as a conclusion, we have seen that code coverage is requested by the various safety critical standards in a lot of industries. But it could be a challenge to implement this on targets with limited resources. So if you use the right techniques and the right tool, you'll be able to get this information. But it's not enough. Some tools are able to do this, but they can't provide help for qualifying the tool. So it's days or weeks of work for you to run this qualification process. So here we can help because we have such a kit in order to help to provide this information to the certification organization. And the smart techniques to run on the target with MCDC, you have seen the reports, so we are very helpful to customers to use that by providing this kind of report. Okay, I'm done. Thank you very much for your attention.